lambda is 0.7. Now, if lambda equals 1, then take this first equation here and plug in 1 for lambda, right? So these two equations here become this. Okay? So you get negative 0.1x plus 0.2y equals 0. And you get 0.1x minus 0.2y equals 0. How are these two equations related? They're the same. If you multiply this one by negative 1, you get this one, which means they're the same equation, right? This equation is just a multiple of this equation. If you add these two equations, you get 0 equals 0, which should be no surprise. Everybody pretty much knows that 0 equals 0, right? But that you got it out of these equations is maybe a little surprising. And you got to think pretty deeply to understand why it works out that way, but it doesn't matter. You can solve either equation. So you get y equals, so you got 0.2y, put the 0.1x over here, you're going to get y equals x over 2. And from this, it immediately follows that the stable population vector is 666 2/3, 333 1/3. Because for that vector, y equals x over 2. Okay, well that's a little aside, you work that out. Thus, xy equals x over 2 I could write that as x over 2 times 2, 1. And the whole thing is, really, you look at this and you see this number has to be half of this. So you could pick any number where this is, any two numbers where this is half of this, and that'll be an eigenvector. Okay? So for lambda equals 1, 2, 1 is an eigenvector. So is any multiple of 2, 1. For example, this, which is a stable population vector, for our basic sane demented model. Now, you have another eigenvector, 0.7. our eigenvalue 0.7. If you do all this and use 0.7 instead of 1, you get a different set of equations with a different solution. But the steps are all identical. You do exactly the same steps with the other numbers. Okay? And that's something I'll ask you to do for homework. Just, you can look at this, imitate it step by step, get the result. Okay? And tomorrow I can show you how that result gives you a picture that'll be very valuable to you if you go into any field that requires a linear algebra course, which is most fields. Matter of fact, linear algebra is more important for fields like economics than it is for a lot of engineering fields. But it's very important in practically all fields. Okay? A lot of your economics models are transition models. Stock market's up, down, even. What's your transition matrix? Okay? Well, that one's kind of hard to get a hold of. There's other stuff that isn't. And you get big old transition matrices, stochastic matrices that are very important for study of how economic system works. Just as an example. And quantum mechanics is all linear algebra. Okay? That's an exaggeration, but it's very heavy.